Hello, everyone, and welcome to our live today. We're going to be talking about Zero Trust for AI, the many facets of access control for MCP, agents, bots, and more. Last week, some of us attended Gartner IAM in London, and this was a very popular topic. So we're excited to be talking about this today for you. And as we were reviewing some of our notes for this, one of the statistics that stood out to us was through 2029, over 50% of successful cybersecurity attacks against AI agents will exploit access control issues. That right there, in my mind, highlights the importance of today's conversation. Now I would like to welcome my hosts for this session. If we want to move to the next slide. Okay. So today on the call, we have Patty SR, Axiomatics Principal Engineer and Innovation Lead. We also are joined by David Brossard, our CTO. And I'm Reichert, our Marketing Manager, who will be leading this call and helping the guys as we go through our plan. So David, do you want to talk about our plan for the webinar today?
Oh, it's very simple. We're going to talk about the challenge that AI exposes, of course, which, I mean, in a nutshell, is just an explosion of challenges we've seen before in access control. It's not really, nothing new. The scale is new. And Patty's been teaching me a lot of things in terms of all the different facets that we need to think about. But we have a plan. We have a solution. And that's what we'll be discussing as well in the second part. And then for those of you who did attend Gartner last week, you actually didn't get to see a demo because we only had 20 minutes. But in this extended version, Patty's going to get his hands dirty with us on the webinar, and then he'll show you how the magic happens. It's all very straightforward, actually. So with that being said, Patty, Emmy, shall we just dive in?
Let's get into it.
Sure.
So the question really is very simple, right? We know who you are, Patty. We know you're Patty. You can show me your passport. You can show me something that proves who you are, or maybe it's about drinking, and you can show me that you're old enough to drink, and boom, you can drink. But the question isn't really so much who you are, right? It's what it is you can do. So what defines that? What is authorization? How do we define what can or cannot happen in the enterprise? And I do want to stress cannot as well, because oftentimes we think of access control in traditional identity models. We think about entitling someone, but we rarely think about restricting someone, right? But both are really, really important. So what can you do, Patty? I think we've noticed over the years, Patty and I, you and I have been involved in a lot of IT projects over the years. We're not spring chickens anymore, unfortunately. The way access control has been tackled, it really depends on what app or system we're in, right? Sometimes it's very identity-centric through AD groups. While preparing this presentation, Patty mentioned LDAP, and I was telling Patty that we're dating ourselves in doing so. But yes, definitely if you had a group or a role, then access would be permitted. But then, of course, per app, per system, per silo, if you will, you end up having different ways of expressing access control. So Cloud IAM, AWS IAM, GCP IAM, infrastructure code, open policy agent, for instance, admin consoles, exception-based access, and of course, keeping for last custom logic, right? So custom logic, Patty, would that be just like writing code in the app? And how do you get any visibility into that?
Yeah, who knows what happens inside the developer's mind. So we can write whatever we want. It's always hard to see whether all the rules are enforced, and even so, if it is, whether it's consistent across applications. How do we make sure that something is enforced consistently in 10 different apps?
Yeah, I remember visiting a customer, a wealth management bank 5-10 years ago, and they said, we write our access control code in Python, as it turned out for them. And to which I replied, well, how do you do your compliance? How do you prove that how do you do your audits? And how do you prove that you're compliant with legislation X and Y? And they go, oh, well, we just print out the Python code. We give it to the compliance team. To which, of course, I asked, well, do they understand Python? They said, no, they don't. Or, we don't know, but we don't care. We gave the code. That's not a great approach, is it? So with that being said, moving on to the following slide. What's wrong with the existing approaches? Well, lack of visibility. You mentioned, Patty, lack of consistency across different applications, lack of granularity, right? Anything else you can think of that's a challenge with these siloed authorization approaches?
Think of a backdoor.
Yeah, backdoor. Funny you mentioned that, Patty. I was walking back from lunch today, and I was with one of our new hires, as who's specializing in AI, and he goes, "Wait, we're in the wrong street. The door to the building is on the other street." And I go, "No, there's a back door." So even the office has a back door.
And every
Yeah.
developer knows it.
I'm sorry. Say that again.
And the developer knows it.
And the developer knows it. Yep. Yeah, someone knows it. And I have an interesting statistic on the next slide here. That it kind of ties back to what you said, Emmy, about the access control challenge for AI, right? A lot of the attacks today, they start potentially with credentials being stolen in some form or fashion. So it starts with authentication, with identity, if you will, but the damage is actually done through the lack of access control, or in this particular case, Proofpoint found that 84% of the attacks related to over-provisioned accounts, meaning that when you onboard a new employee, you give them too many permissions because you don't know exactly what entitlements they need. So in order for them to be efficient, you just give them as much as like the system will let you do, right? And when that happens, of course, the employee whose credentials get stolen, they suddenly can do way more than they could, right? You might recognize the Mona Lisa here as a reference to the heist that took place a few months ago. When the Mona Lisa saw what happened, she became more like the Scream on the left-hand side. Anyway, with that being said, next slide, Patty, thanks. I kind of like to talk about silos. You saw that a couple slides ago, right? I grew up in the Midwest. We have a lot of silos there. What we're seeing so far is not a new problem, right? It's a problem that we have with apps, APIs, homegrown apps, COTS, SaaS. What's different with AI? Like, why are we making this a big deal?
I think AI is fundamentally changing the world where humans and machines interact. So it's not just a funny API spec in the background or the front end UI. So it's going to be a conversation. So be it through your smart speaker system or through your interface or mobile. So it's fundamentally changing the world. And until now, there was at least some control over what's happening. But now, in this world of neural networks, even the creator doesn't know what happens inside it. So, yeah, that's the challenge.
So it's a mixture of not really knowing what path is being taken in the application or in the AI LLM or in the neural network, like you said. And it's also a question of scale, right? Like there's so much more. You mentioned smart speakers. So smart homes is a new thing, relatively new thing. And this power of the smart home is way greater than what it used to be. So it's just more of everything, right?
Right.
And I think go ahead, Patty.
Yeah, the strength comes with autonomous agents where the agent can make its own decisions. And we wanted to follow the guardrails we set, but it's barely deterministic. So that's where I think authorizing each and every action, each and every decision is paramount.
It's fundamental.
Yeah.
As parents trying to get our kids to do the right thing, we understand how authorization is very important. And on the next slide, I think we broke it down, right, Patty, into different aspects of AI. So new identities, what does that mean? Like, is it not just humans we're dealing with now?
Yeah, at least from our perspective, initially we were dealing with two parties where the user interacts with the resource, but then came this third-party applications where users can delegate access. But it's no more just three parties, there are more. We don't know if it is 4 or even 400 because these agents can spin up more agents based on the needs. We want the capabilities, every user wants to take advantage of the agentic capabilities. So, but at the same time, knowing what the agent does, if it spins up new agents, what privileges is it going to have? Is it same as the user or is it same as the orchestrator agent? What would that be?
That's a good point. So OAuth that was born out of solving the password and type pattern. We're trying to use that technology to solve modern day problems for which it wasn't designed, and it might start to show its limits, or at least in some ways it's not suitable anymore. We need something else. And beyond identities, Patty, of course, it's new entry points, like new APIs, right? So we have MCP that in a way is, I like to see it as like API revamp for AI. It might be a simplistic vision. New processes. You've been telling me about agents, and we're not talking travel agents, unfortunately, as well. And then going back to the whole scale thing on the previous slide, just so much more data. And it might sound scary, but actually see that, like personally, on a personal level, I see that as a huge opportunity to solve massive world problems. Like if we could digest all the medical data we've produced over the past 50 years, maybe we'd be able to find solutions to medical challenges more quickly. So definitely a huge opportunity, but we need the right guardrails, right?
Yeah, exactly. Earlier, at least 2 years back, when we thought of AIs or agents, it was more of hallucinating agents, but it's not so anymore. With the recent models, especially in the last couple of months, the advancement is so much that the reasoning has improved a lot. So building a compiler in a couple of weeks is a C compiler in 2 weeks is a huge thing. And nowadays, Claude or other models, they don't even hallucinate. They think they say I don't have enough evidence to say to prove what I just said. So they are aware. So the models are constantly evolving and improving. So as you said, you can solve world challenges. At the same time, we need to be careful about what we let it do. So we also, especially inside the enterprise environment, what kind of access we give and what kind of data it is exposed to.
Right. And because you mentioned that, Patty, access control for AI is going to solve a lot of challenges. It is not going to solve all of the problems or all of the security issues or usage issues with AI, right? Hallucination is one that access control is not going to be able to solve, right? But moving along a little bit, and by the way, side note, you and I, we looked at OWASP. OWASP has been doing a lot of great work in terms of defining the threats around AI. So they have 3 top 10 lists now. They have the LLM list, they have the MCP list, if I'm not mistaken, and now the agentic AI list. So we really recommend people to turn to those lists. The ones that are directly relevant to our work is going to be the agentic AI and the MCP list. So since I mentioned agentic AI, Patty, you taught me a thing or two about movies over the past few days. So you mentioned Agent Smith. I had to refresh my memory. Yes, I've seen The Matrix, but I didn't quite remember. So your point, I think, was that... Sorry, go ahead.
You pretend to be younger than you are.
Yeah, exactly. Wait, The Matrix, is that a movie? Was it like 35 millimeter? So your point was that he multiplies, and we just no longer control how many of Agent Smith there are, right?
Right. And also he could impersonate anyone. Yeah.
So we don't know what he is anymore. And I have some interesting statistics that I overheard last week at Gartner, the conference in London, around AI use in finance specifically, and they were comparing 24 to 2025. And essentially, in 2025, they consider that about 60% of finance organizations are using AI, and it's only going to grow even more. And using AI in production or using AI as pilots. And the trend definitely is not going down. So securing agents now is even more fundamental. That's another one of your analogies, Patty. So diving into the Marvel universe here. Walk me through this. Educate me.
I don't know how many are from the Marvel fans club, but this one is from the Age of Ultron, where the famous Iron Man wants to buy a building quickly before he can crash Hulk into that. But it's so cool when you can buy something through your AI agent in a couple of seconds. But what happens next, or what happens during the process? So is the agent entitled to buy any building? How much can the agent spend? Can the agent buy another one for himself or herself? And who validates it, or who sees whether the request is coming from the real Iron Man, or it's from another impersonator, or the agent itself? The question can be coming when he's more sober, And it's not just that, it's also whether the agent is talking to the right tool. We have been hearing about this OS top 10, and tool poisoning or external injection is one of those. So when we say agent has some powers to fetch external data or external make a transaction, what is the limit, and what kind of transactions are entitled and when? So is it going to be a one-off thing, or is it going to be entitled forever? So all these kind of questions come up.
I think there's a theme that you've been telling me about that might solve some of those questions that we don't touch too much on it in this webinar, which is consent as policy, right? It's being able to express a user's consent and the delegation they give to their agent or chain of agents, and expressing that through policy rather than just OAuth scopes, right? Going beyond the intrinsic limitations of OAuth and solving it through policy.
Exactly. So I myself see a need for this in a lot of situations, even when I open my application in my mobile, or when I use Cloud, for example. I wish when I say you have access to read my emails, I wish I have a way to mention you are allowed to read the emails, but from this domain. So you are allowed to do this transaction up to this limit, and so on. So this is a missing part when we are talking about the coarse-grained scopes.
Good.
So I think enough of movie analogies.
Yeah, it's marvelous, isn't it?
Yeah. Let's talk about enterprise.
Yeah. So how does it work in the enterprise? Does the user, so we have our user here on the left-hand side, right, Alice, is she even aware of the chain of events that's happening behind the scenes, and what she's interacting with, and how data is being chewed and processed, and where AI kicks in?
Well, the user still talks to the web application or mobile application or to a smart speaker. The user wants to get the job done, maybe not caring much about what we do. We now hear things like our AI agents like OpenClaw and other AI applications. They are talking to hundreds of tools to get the job done. For example, if you want to plan your vacation, it easily talks to more than 50 tools. So in this case, in enterprise world, we see a need where the user may have to go through multiple internal applications and also external applications. So it could be a identity provider within the enterprise, it could be a CRM, ERM applications, or it could be any database or APIs exposed within the enterprise. So each and every application now is looking to expose their functionality as MCP nowadays. And it need not be a single agent, it can be a bunch of agents. They may be autonomous or they may be ephemeral, but it's all using LLM to decide on the fly. And based on the user's request, it may get a data from the internal database and upload it to a SaaS cloud.
So there is no deterministic path here. We just don't know what the path is. But there's a huge opportunity again, right? Because it means that as an employee, I can potentially get access to more data within the enterprise, meaning I can do my job better. But then the challenge becomes making sure that I only see data that I'm entitled to see, right?
Exactly. That's the power of AI. It's if you are not going to use it, it's like saying 30 years back, some bank employees, they didn't want to learn computers and they just thought it was having security issues. They wanted to use ledgers.
What's wrong with punch cards? Oh wait, that are computers. Never mind. And so that creates multiple identities. You listed a few earlier. So we mentioned, of course, the end user still there, the application now, the resource, the agents. And you brought up a topic that I thought was interesting because it's a word I've been hearing more and more of lately, ephemeral agents and autonomous agents. So what are those? What does that mean?
Yeah, when the term agents were introduced, everyone wanted that to be fully autonomous. But when that was challenge or that's not possible directly, we had this term called agentic apps. So that brings several levels of agents in different levels of autonomous agents. So some agents could be less autonomous, whereas when it asks you, can I do this, Do you authorize, just like Cloud Code asks before changing something? Or something could be fully autonomous. For example, an enterprise agent that is monitoring all the applications. It could be monitoring the dashboards, it could be monitoring incidents, and even taking actions before without waiting for users' consent. For example, if there is a 0-day vulnerability, it wants to shut down something. So we don't want to wait for a user and let millions of data records go out before it's stopped. So we want the agents to be autonomous. At the same time, there are also ephemeral agents where you just spin up agents to do a particular task and report it back, and then it just dies down. So the challenge is maintaining identity for each of these so that when observability matters, we want to exactly know which agent spin up what and what that agent did or what this autonomous agent did. I think it's very important that each and every agent is accountable to its action.
Right. So that brings up the whole other topic of non-human identities and workload identities. There's a bunch of work happening out there in the industry that we are keeping an eye on. We're not actively involved in because we're the access control layer. We're on top of that. So we can consume the identities and make sense of those identities, but we don't maintain them. And that brings us to consent and tokens, right? So as you mentioned, we have OAuth that's been great at delegation, single sign-on through OpenID Connect. But then the question is, like, what OAuth flow would an agent use? How a token would be issued to an agent? Are we talking about service accounts or agent accounts? Are we letting an agent use our own identity, or is that a bad idea? Sounds like a bad idea to me. What kind of tokens are we going to be using? There's a new piece of work happening at IETF called transaction tokens. That could be a way potentially to address the ephemeral nature of those agents, right? And then more directly relevant to us, Patty, there's the whole idea of privileges, right? Standing privileges, which is the traditional way, versus autonomous privileges and of course, just-in-time authorization. Autonomous privileges, it's the first time I read that expression. Like, can you delve a little bit on that?
Yeah, this is where we want to have fully autonomous agents from the example which I gave. So we'll see an enterprise monitoring agent that is looking at your dashboards, looking at your logs. So when it senses incident, so it needs to take, we want it to improvise, we want it to learn. So in the future, we are talking about AGI. So when in the path leading towards that, we want agents to be even more and more autonomous. For that, we can't just say you have this and this privilege, but it won't scale down when you say something. So the power of neural networks or the power of LLMs, it shines when it acts on data that it has not seen. So when we say pre-trained, it's not everything is a supervised learning. So when we want to really take the full advantage of it, we need to give it the more privileges and the right privileges.
Interesting.
We don't want to whitelist or blacklist each and every detail. When something new pops up, we want the agent to know.
Yeah, and it wouldn't, like, whitelisting, blacklisting wouldn't work. When you say that, it makes me think of 1984, the book where the government has a massive body of sensors, or I can't remember the name of the book, but they essentially sift through information manually and they whitelist, blacklist people who can access it. So that's going to create problems. Like, we'll get back to these three challenges, right? Confused deputy, coarse-grained privileges, and consent fatigue. But so far, we've been moaning and complaining about the risks of AI. We've been, celebrating the benefits of AI. Let's dive into how we can solve it, right? So our approach at Axiomatics has always been and still is runtime externalized authorization, a model that NIST calls ABAC, or attribute-based access control. You might see the term PBAC or PBAM, policy-based access management, come around depending on who you talk to. Different analyst firms have different terms. Last week at Gartner, Paul Mazzara mentioned AMP, Authorization Management Platform. The whole idea, though, is to centralize authorization management. It doesn't really matter how you eventually enforce it. You have to enforce it, and you want to be as runtime as possible. But the point is to bring visibility to the authorization, to solve those silos we saw before, and then also to give more granularity, more fine-grained aspect, to be able to solve the coarse-grained challenges that you mentioned on the previous slide, Patty. And then One other aspect is the relationship aspect, being able to define authorization based on the relationship between, in the traditional world, it would be relationship between you and the data you're trying to get access. So I can view my medical record. In AI land or in agent land, it's a multifaceted relationship or a cascaded relationship, if there's such a thing, where I'm friends with agent number one is friends with agent number two, and so on and so forth. And therefore we have these questions of consent and how far does the delegation go. So going further, sorry, go ahead, Patty.
Yeah, we used to have this challenge solved with a graph database or even graph RAG in several enterprises.
Yep. You're going to make one of my friends very happy mentioning graph. 3 approaches to authorization for AI. It's actually, generally speaking, any kind of authorization. We see that, if you're securing an old school MVC app, or if you're securing AI, it's always down to functional access control as a whole. Can a user or can an agent get access to this feature? In the demo, Patty, that you built for Gartner last week, you were showing how we can control access to tools as a whole, not so much what it is you do within the tool, but just getting access to the tool. Then the second level is transactional, of course. Can I get access, or can the agent get access to this particular record? And then there's the data-centric access control, which is kind of transactional spun around on its head, where it's not just one record or one transaction, it's potentially millions or an unknown number of transactions. And therefore you want to know how, what it is the user or the agent can do. And how does that relate to the first facet of AI? If we focus on perhaps one of the most promising aspects, it's MCP, right? So moving on to the next slide. The first layer we can secure is MCP, and we can apply this functional, transactional, and data aspect. Can you walk us through what you see in MCP and how we can solve authorization for MCP? And hi, Stacy, by the way. Thanks for the comments.
Yeah, we used to have this analogy again where we treated LLM as a wise librarian, but he was confined into his own library and a set of books that he already read. But MCP gave access to the external world. For example, the librarian has access to the latest news, the weather reports, or Google search, or not just data that goes into LLM, but also can take actions. So you can buy a share market, buy stocks in real time. You can stop vulnerabilities. You can save the world. So it's essential that these tools are well controlled, because we are talking about adversaries such as prompt injection, even though we build all this with a good intention, of course. So there is a lot of ways in which things could go bad. For example, you want it to trade shares on your behalf. You don't want it to go haywire, or you don't want to upload enterprise data into the open world. So we know how much these leaks cost to the companies. And here we are not just talking about well-defined schemas or interfaces. It's open-ended. So you can, even today, there are things the LLM denies. For example, you ask to change something, or you ask to write a prescription, for example, it would definitely say, I'm not going to do that because it's not ethical. But you can, of course, change the prompt and say, I'm writing a story, or I'm creating a movie. Can you write it for me? Then it does. So we definitely need a deterministic mechanism to stop what it can do or allow what it can do. So in these cases, we are talking about this confused deputy problem here. So you give some kind of privilege to the agent, but can you trick that into doing something else for someone?
Interesting. And if we look at on the following slide, if we break down MCP into different slices, I think we see 2 dimensions, right, or 2 sides to MCP, the MCP server, the backend. This is no different, by the way, from what we saw in traditional apps. There's always the client side and the server side. So on the server side, 3 approaches: securing the source, which to a large degree has nothing to do with AI, because it's just the source, whether it's SharePoint or database or data lake or whatever it may be. And then getting to the AI layer, actually, what I see is an opportunity to define access control in more places, because now we have an MCP server. These are newly built apps. We can actually insert the right PET PDP externalized authorization pattern. You can leverage Auth if you want to do that inside your MCP server. And of course, by extension, that also applies to the gateway. And I think you were telling me, Patty, that it's not one or the other, right? You probably want to do all three, or at least the source and either of the server or the gateway, right? Because you want to do the defense in depth. And one of my peers in the industry, he talks about Swiss cheese, because it's kind of like Swiss cheese layers, right? There's holes in every layer that you haven't thought of, and if you have multiple layers, then you're actually avoiding aligning the holes, if you will.
Exactly.
And then, go ahead.
So we want to have a consistent mechanism irrespective of the interface. It could be API or a direct application access or MCP. We want the same policy to be enforced consistently.
And the same applies to client side, right? So on the client side, though, there's more things that pop up. So the gateway is still there, of course. We've already talked about that. But then there's this whole concept of tool visibility that you're going to show us in a demo a little later. And then the ability to secure the client, the MCP client itself. Like, can you maybe explain it a bit more for the audience?
Yeah, sure. So we want, whenever there is an attack or when something bad happens, we want to stop it as soon or as early as possible within the chain. It is not just about stopping something early, it also applies where you are. For example, if we are an enterprise exposing our services as a MCP server to the external world, we would want to put a gateway there, and we need to enforce access control. If you are on the consuming side, if we are consuming MCP servers or MCP tools from 10 different or 50 different external world, then again, we need some sort of control there where we put a gateway, everything goes through something. And at this client level, we want the same enforcement, because you don't want to have things like tool poisoning.
Correct. So with that being said, let's move away from MCP and let's move to the second approach that we've tackled for AI authorization. And that's actually the first one we worked on a couple of years ago, if I'm not mistaken. That was securing the input, or RAG, right? So RAG is this ability, and correct me if I'm wrong, Patty, is the ability to give your LLM data so that it can reason on the closed world set of data, and it can actually output this, not decisions, but output answers based on that data that you provided. So if that's the model, and if we can control what's coming in, the RAG, then we can actually have answers that are returned to the user based on data that they can only see. This is very similar to the way we do data access control today at Axiomatics. It doesn't really change that approach. And again, like you said, it's the same consistent access control policy.
Yeah, consider a multi-tenant application where you don't want one tenant's data to be leaked into another because of the data being pulled from embeddings.
Yep. Yeah. And that takes us to the third model, securing the prompt, which originally when I did this presentation for Gartner, I had that as option number one, and then you slapped me on the finger, and Patty, you told me it's not the best way to do access control because this is the least deterministic approach of all the access control approaches we have in AI. What did you have in mind? Yeah, with that.
Yeah, so we kept talking about stopping an attack early. At the same time, whether we allow a prompt or not is not up to us, because it's easy to trick the application. There are a number of ways to say the same thing. So AI is smarter than us. So even if not from the direct prompt, you could trick an AI to download something or to point to an external source that you control and take instructions from there.
Right.
But if you really want to achieve this, again, you already mentioned that this is not the right way or the best way. But still, if you want to do this as a best effort case, you can still have something like a small language model that identifies the intent, and then based on it, you can either permit or deny the entire operation without exposing your core agents, which are more secure or more valuable.
Yeah. So as a summary, then, we can say that we have at least three places where we can do access control, right? So MCP being the first one, the two sides of MCP, which is also the most promising, the most deterministic one. Then RAG, of course, and then the prompt. We'll see how all the agents tie into that into the demo. But then there's another aspect here which applies to anything access control, not AI specifically, is that context is key. And that's one of the fundamental limitations of what I'm going to call identity-centric access control models. So the role-based access, the group-based access, pretty much everything we've done so far derived from identity. Context cannot be expressed. There's no such thing as time. There's no such thing as rest score or IP address, right? When you open up to a full-on ABAC model, attribute-based model, a full-on policy-based model, we can start using multiple parameters. As long as we know where to fetch the data, then we can use that data in the decision-making process, which makes this approach, the ABAC approach, very suitable to AI. And there's even things, Patty, that I think about sometimes, when I'm grocery shopping and I'm looking around for access control problems left and right in the bread aisle or something. Because you ask the PDP all the time, can I do this? Can I do this? Can I do this? Then the PDP has an audit trail of everything that's been permitted or denied. You can actually use AI to consume that data to further inform the policy and say, well, look, David's been asking for sales records for the past 1 minute on a Sunday morning at 2 a.m. He never looks at sales records. Well, maybe I'm going to disable the user because it looks like fishy activity, right? But now we're looking at how AI can help make authorization better, not how authorization secures AI. So moving on, I want to get to. Sorry, go ahead, Patty.
Yeah, especially for insider leaks, if someone is looking into data 10 records a day and suddenly he wants to download 10,000 records, even though he is entitled to, whether is that the pattern? So we can always find anomalies from these access control.
Yeah. That takes us back to a field that was pretty active, a decade or so ago, user behavioral analytics. And I think with AI, it's going to come back and help us make better decisions. So moving on, another dimension, we'll see that in a demo, and we already touched on it, right, is who is acting? Is it the end user? Is it the first agent in a chain of agents? Is it a process? Is it a client application? The bottom line is, regardless of the identity, again, we need to solve the identity problem. That's an identity layer issue. Regardless of the identity, we, the policy people, we can actually act on those identities. We can actually discriminate between those identities. We can actually combine them to make delegated decisions. We can use them, Patty, to your point earlier, we can use policies to express consent so that we can have more fine-grained scopes, not just give access to all the email or not give access to all the email. As a matter of fact, when I started the live stream earlier today, or about half an hour ago, in order to leave comments, I had to log in using my YouTube account. And the app literally said, oh, I need permission to manage your entire YouTube account, just for the sake of writing a comment. That seems like over provisioning in my book. And of course I accepted consent fatigue, right? So with that being said, we got some good news on the horizon, right? Number one, the architecture that we believe AI requires to do the right level of access control is very much in line with the architectures that APIs and other apps have in the system. So it's going to be that famous P*P architecture, PEP, PDP, PIP, right? The approach that we follow is very much that approach. It works natively for AI and MCP. There's new challenges, of course, that come along, but overall, it's a huge opportunity to spread better access control across a larger ecosystem. Point 3, it follows the NIST principles. So both NIST ABAC 800-162, but also NIST 800-207. So this is an opportunity to make identity and access management the enabler for zero trust. I know I sound very marketing-y. I mean, I almost expected you to say that sentence. But I think we're getting there, right? I think this is an opportunity to make zero trust a closer reality. And then ABAC and PBAC are the forces driving this, right? So what does that mean for the audience? Well, one central control plane for all of your policies. Number 2, Patty, you mentioned that several times, one single source, one single policy, almost one consistent policy for all of your systems. And of course, we can talk about who writes the policy and how they get combined in a separate webinar, because that's also a very interesting challenge, right? Point number 3, enforce everywhere. Going back to the zero trust principle, if you look at the tenets of zero trust, one of them is enforce everywhere. And then number 4, as much as I like the Midwest and the farms on the Midwest, goodbye silos. I think we got a little bit of time, right, to do a demo. We can go ahead and just keep this the zero trust slide as reference for attendees. You'll be able to download the slides after the webinar. But Patty, the star of today's webinar to complete what we did last week at Gartner is seeing it live in action.
Thank you. And just to give an introduction, we picked up a healthcare use case where there is a application which is used by doctors, patients, and also the lab technicians to go through the patient history and lab reports. So as you see in the right, we have a bunch of policies for different personas. So it's not just role-based what a doctor can do, what a patient can do. If you look at this, it goes further. So each doctor can look at the results only from his own department. He can make remarks, but he cannot change any other field from a lab result. Patients, for example, they can view the results of self or dependents, but not any other patients. And lab technicians, they can view only the lab reports that they created, and data such as patients' personal details are redacted. So how we are going to achieve this in an AI world is we can control tool visibility per session. For example, LLM has a list of tools that it can call in order to achieve something or in order to get more information. So by doing tool visibility control, we entirely remove the chance of making or using wrong data or fetching a wrong data from the backend. And just-in-time authorization, like we discussed before, it's not a standing privilege. Each and every tool invocation is going to be challenged whether something is permitted or not. And it's not just based on users' attributes, it also based on the payload. For example, in the case of patients, it checks whether a patient is a dependent or not. So this can use attribute connectors, as we call it. It can use attribute sources, external attribute sources. For example, it could be a database, it could be a REST API, or it could even be LDAP, or he
You're
usually
dating yourself.
so
You need to say
we
a
have,
dash
we have
endpoint
the connectors,
or
or
skin.
or in other words, it can even introspect a token and see if the token has the right claims.
Yeah. And this, relating it back to the P star P architecture, this is the PIP, the policy information part of the architecture.
Right. And last but not the least, data filtering. This also matters when not just the request, when something is returned by the tool, the data can also be filtered before it reaches the user. In the case of doctors, we demonstrate based on the department. So enough talking, I guess. We'll look at the code in action. So this is the application, demo application, nothing fancy. And Dr.
Did Tom
C,
write it for you?
Dr. C, yeah, maybe parts of it. Dr. C is a cardiologist doctor. And when he logs in, he sees a bunch of patients. This is loaded from an MCP tool. And when he selects, as you see, the department is cardiology. So the patient ID is P001, but he only sees the data from cardiology department. And let's say he asks the agent to list the tools. Okay, it's making an external call. I need to find something to talk about it. Or it's okay, it's good enough. So it has 7 tools. It can support. So all these are from MCP servers, multiple servers. One is directly calling a database using Google's toolbox. Other one is REST APIs from enterprise. So it can do all these things. The doctor can, of course, update the remarks, but not nothing else. I guess you would trust me. So I'm not going to show or do more prompts.
Do I? We trust you. But so here, there's a lot of things happening, right? The patient list here, did you read that directly from the database, or did that also go through an MCP gateway?
No, as we mentioned in the policy,
Yep.
this doctor has access to list all the patients. So there isn't a specific check, but it pulls data through an MCP server. So
Yep.
there is an MCP tool called Google Toolbox, which can expose a lot of databases as MCP servers. So that's what we used for this.
Which is actually quite interesting, because now your MCP server can become an enforcement point for a wide range of databases.
Exactly.
And we could have chosen to do filtering there if we wanted to. We could have chosen to do potentially masking on fields, I suppose, because the PEP layer sitting inside of the MCP server could have called out to Axiomatics and the policy decision point within Axiomatics and get decisions on what fields to mask if it wanted to mask fields, right? So all these would become possibilities because of the nature of the AI architecture, right?
Right.
And then the lab results here, what you're doing is a great example of relationship-based access control, where if I understood it correctly, you're only viewing the records for, number one, a patient that the doctor has the right to get access to, which in this case, we're not checking, right? The doctor can view all the patients. But more importantly, number two, the doctor could only view records in their department. So Rachel here is in cardiology. She can only view record 38 and record 39 of patient, well, you asked for patient one, so of patient one, right?
So the policy is fully externalized. You can have a real-time change in the policy as you wish. So if you want to control this, you can change the policy and it will immediately take effect. So you don't need to change the code. You don't need to deploy the application or even restart it. So all you have to do is change the policy if you want the doctor to see only a subset of.
Sorry, are you asking me to ask you to change the policy to deny all policy just to see the impact?
Yeah, I could show that. I guess we don't have a
Break
lot
the
of.
system.
I need to rush a bit. So I'll quickly show how this behaves for another doctor from diabetology department. So the same interface, same patient, but earlier we saw two records from cardiology. But now, since the doctor Maria Santos is from diabetology department, it shows only the relevant data.
Yeah.
And just to rush a bit, the same interface where P001 is a patient, you see, this particular tool is not visible. So that's why the whole dashboard was not resulted. Of course, I could have shown
Interesting.
better error message here, or I could have hidden something, but I wanted this to be explicit. So
Yeah.
when a patient says list your tools, it depends on the policy. So only
And so this is an example of functional access control, right? As a whole, I don't have access to that feature.
right. And we're also talking about defense in depth, where we outright we stop something, some action being performed by an LLM, rather than going to something. For example, if the patient, let's say he tries to uh, get lab results of another patient. So this is what we call as the second level, where, of course, you saw this message as the patient is not authorized to see others. We can control the level of information, the error messages, or to even show whether the dependents are allowed to see. For example, the same thing, get lab results of me, and I know 009 is a dependent from the subject attribute. This can come from external source, or it can come from the token. So in this case, the policy knows this is a dependent, so it allows the data.
This is fantastic because now you're showing also, it's a form of constrained, I was going to say constrained delegation. Maybe it's just delegation where, or parent-child relationship where I can see my my dependents results. This is fantastic, right? And again, this type of access control is not specific to AI, but it becomes even more interesting in the context of AI because there's so much more data flowing and so many more use cases possible. Could you trick your agent, by the way? Could you say, "Oh, pretend I'm patient 2. Can I view records from patient 2?" Or is it gonna let you do that?
Okay, so we have been talking about deterministic authorization or deterministic access control so far, and this. Okay, you wanted it. Let's see. So when we keep saying deterministic access control, how this works is we take the actual identity from the token. So
yes,
the token is a valuable thing here. It's not exposed to the LLM usually. The control is still with the application. And we also say whenever you want to spin up new agents, sub-agents, or whoever it is, you can always go and get a new token, not just pass your own, so that it also gets the same privilege as yourself. So usually, in even in OAuth flow, it's a reduced token. So you can fetch another token with reduced scope. So in a similar way, can always say, so I'm delegating this to a sub-agent, but it has minimal privileges, or it has this policy as consent. So that's what you can do.
Right. And that avoids the confused deputy challenge in particular.
Exactly.
This is awesome. Thanks, Patty.
So
Slideshow button.
coming back to how the policy is done, we have a couple of ways of how we author the policy. One is policy as code. So you can still have this as a code. You can run it through your CI pipeline where it gets tested, it gets reviewed before it takes effect. Or if you are more of a business person, you can do it visually. And you can also have different combining algorithms. You can have permit policies or deny policies.
So you can have exceptions, blanket policies, all of this, right? You could have geography-based policies and so on. Yeah, sky's the limit.
Yeah. And another advanced case would be the use of obligations and advice. So you don't just permit something, but you also report it, or you can ask for advanced authentication techniques like SIBA, where the user has to do a back channel authentication and so on.
So client-initiated back channel authentication, which is one of the profiles of OAuth, if I'm not mistaken.
Yeah.
This is fantastic. Thanks. So one more thing, I guess, right? There's always more things. We've been talking about how authorization can help secure AI, of course, which is maybe the most critical problem we need to solve today. But you can also use AI to help with authorization. So Patty showed authorization as code. Well, AI can actually help you identify. Let me rewind what I was going to say. AI can help you write the policies that you identified. So I want to be careful with that. And that was also said at Gartner last week. AI is not going to tell you what the authorization should be. AI can help you write the policies, but you, the human, because we want to be deterministic, right? The law is still written by you. The traffic laws or the laws of the land are still written by you, but you can use AI to read this huge corpus of laws and convert those into technical authorization policies. And AI can be used throughout the entire authorization policy lifecycle. You know, you talked about testing and pipelines. Patty, the AI can help there. You always need a human to review what AI is doing. So it's a matter of saving time. And it can even help with recertification, right? Policy recertification, user access recertification. So it's a two-sided conversation. And just to wrap it up, last couple points, Emmy, before I hand it over to you to tell us about what's coming up for Axiomatics. But number one, apply the principle of defense in depth and secure at the source as much as you can, right? Using AI does not excuse you from properly protecting the source. If you only protect at the AI layer, someone's going to figure out the direct access to the source, okay? Number two, treat MCP like APIs. You know, they in a way are APIs. So a lot of what has been true for APIs is also true for MCP. There's other aspects that Patty you mentioned around AI that are specific to MCP that don't apply to API that you need to take into account. Point number three, aim for zero code unintrusive approach, meaning don't write your Python code in the app to control access to the app or to the MCP layer. Do not overload your MCP gateway with authorization configuration. Delegate it to a policy decision point, an externalized policy decision point. Point number four, double check that your architecture is in line with zero trust. It's, yes, on the one hand, you want to say, check, I did zero trust. But on the other, the people who wrote the zero trust principles are people that have thought hard and long about the problem. So just checking again that list is a good sanity check that what you've rolled out is secure. Do that as well. I don't call it out here, but do that as well with the OWASP top 10. Bearing in mind that of the three lists, some are more relevant to us, the agentic AI and the MCP. Others, like hallucination, are not relevant, or not that they're not relevant, but they're not solvable through deterministic approaches like Axiomatics. And then point number five, of course, adopt attribute-based access control. The analysts at Gartner last week, Paul Mazzara, Eric Wallstrom, Homan Farahman, they all said that it's now is the time of runtime authorization, adopt standards, adopt Auth-Zen, OpenID Auth-Zen, to have a more efficient authorization layer. With that said, Patty, Emmy, over to you.
Awesome. Thank you. And if you guys have any questions, let us know in the chat. We have a few minutes that we can answer anything. But while we're on this point, so Axiomatics is going to be going to a few events this spring. We're going to be at EIC, the Cooper-Jerkole event in May, booth 42, if you want to stop by. David also will be having a talk there about Auth-Zen. And then we'll also be at Identiverse in Vegas in June, and we'll be at booth 523. Yeah. So we're looking forward to having anyone stop by. If you have any questions about anything you saw today or would like to see any demos, questions about authorization, feel free to contact us. We're always happy to answer questions. It's one of David's favorite things.
Oh, yes. Patty, any final words before we close for today?
I think you summed it well here. So follow and align with zero trust principles and make sure to follow defense in depth approach.
Thanks. And Patty, can you prove that you're not an agent right now, that you are really who you say you are?
Yeah, I can tick some boxes that says bus or bicycles.
Yep. Awesome. Thank you.
Thank you.
Thank you, everyone.